Question 1. What we need to do is to set up a table. So x cubed, x squared, x to the 1 next to the power of 0. I've got 1x cubed minus 6x squared, 5x and 12. My table looks like that. Now, x minus 3 is what we have, so we can take the 3. 0 plus 1 is 1. 1 times 3 is 3. Minus 6 plus 3 is minus 3. Minus 3 times 3 is minus 9. That gives me minus 4. And minus 4 times 3 is minus 12, which means we have a remainder of 0. A remainder of 0 means that x minus 3 is a factor. That's part A. Part B, we want to fully factorise and then solve. So what we have then is x cubed minus 6x squared plus 5x minus 12 can be written as a product of the factor x minus 3 and the quotient. Remember, this is the quotient here. So that's 1x squared minus 3x minus 4. It has to be fully factorised. Four and 1, minus and plus. We want to solve. I'll put a 0 here then. And what we can say is that, well, this bracket gives me x equals 3. This bracket gives me x equals minus 1. And this bracket gives me x equals 4. So there are the three solutions. What we want to do is to list the values of a, b and c. This is a problem that involves using the discriminant. b squared equals 7 squared, which is 49. 4ac, 4 times 2 times 1, that's 8. So b squared minus 4ac is 49 minus 8, which equals 41. And since b squared minus 4ac is greater than 0, there are two real distinct roots. Part A, we're going to use the form x minus a all squared plus y minus b all squared equals r squared. So it will be x minus 2 all squared, y minus minus 5, so I'll write that as plus 5, equals 7 squared. We could write the 7 squared as 49, but that's perfectly acceptable. Part B, what I'm going to do is to write down the general form, x squared plus y squared plus 2gx plus 2fy plus c equals 0, and directly underneath it I'll write down the equation that we're given. Then I can compare the two and be sure that I'm getting the correct values of f, g, f and c. So 2g is minus 6, g is minus 3, 2f equals 4, so f equals 2, and c is minus 3. Now the centre is minus g minus f. In this case then, that's minus minus 3, which is 3, and minus 2. The radius squared is g squared plus f squared minus c, and that's minus 3 squared plus 2 squared minus minus 3. 9 plus 4 plus 3 is 16. So the radius then is 4. Question 4. What we want to do is to substitute the equation of the line into the equation of the circle. So I'm going to replace y and y with 2x plus 3. So x squared plus 2x plus 3 all squared minus 12x minus 10 times 2x plus 3 plus 41 equals 0. Expand and simplify. That's going to be 12x plus 9 minus 12x minus 20x minus 30 plus 41 equals 0. Start gathering together like terms. Well, x squareds, we've got 5x squareds. 12x, take away 12x, 0 minus 20x. 9 plus 41 is 50. 50, take away 30 is 20. I'm going to divide by 5. I can then factorise. Only one point of contact. That means that line is a tangent. What we're going to do first of all is to work out the gradient of the radius, because we know that the radius, or we should know that the radius and the tangent are perpendicular. So, gradient of the radius, 2 minus minus 1, 4 minus 2. So that gives us, that's 3 over 2. That means that m tangent is minus 2/3, since 3 over 2 times minus 2 over 3 equals minus 1. The product of the gradients of perpendicular lines is equal to minus 1. You need to state this here. That's important. So what can we do next? Well, we can use the form. We now have the gradient is minus 2/3, and we have the point 4, 2. So I can use the equation y minus b equals m x minus a. Y minus 2. Remember, this is a and this is b. Y minus 2 is minus 2/3 x minus 4. Multiply by 3 to get rid of the fraction. 3y minus 6 equals minus 2x plus 8. And the final line then is 3y final line, the final equation is 3y equals minus 2x plus 14. Question 6, straightforward integration. What we need to do first of all is to prepare the second term. So I'm going to bring that, the x squared term up, and it becomes x to the power of minus 2. And integrate, so increase the power by 1, divide by the new power, increase the power by 1, divide by the new power. It's an indefinite integral, so we must include the constant of integration c. Now we need to simplify. So 3x squared. In this term, these negatives cancel to give me a plus. And we don't need to write this line, but you might want to bring the x term back down, and this is what we get. Part A, very straightforward this question. Integrate 7 cos x with respect to x. When we integrate cos, we get sine, so it's a straightforward change. It's an indefinite integral, so we must add on the constant of integration. This is similarly straightforward, except that when we integrate sine, we get a negative cos. So it's negative 1/2 cos of x, again, plus the constant of integration c. A definite integral, first thing we have to do is to expand the brackets. X minus 2 all squared. We had a square bracket earlier on, and I didn't show this working, but it is very straightforward. So it's x squared minus 2x minus 2x plus 4, and x squared minus 4x plus 4. You already know how to integrate a bracket like this. I suppose it doesn't really matter how we do it. So we're integrating from 1 to 4, x squared minus 4x plus 4 with respect to x. Increase the power by 1, divide by the new power. Increase the power by 1 and divide by the new power. Now 4 divided by 2 is 2, so I can change that 4 to a 2. Plus 4x, we don't need a constant of integration because it's a definite integral. Four cubed over 3 minus 2 times 4 squared plus 4 times 4. One cubed is just 1. 1 squared is 1 times minus 2 gives us minus 2 plus 4. So that's 64 over 3. 4 squared is 16 times 2 is 32 plus 16. And we have 1/3 plus 2.